All right, this is lesson 3.7. We're still doing implicit differentiation. We're trying to write the equations of tangent and normal lines. This is number 33, which in your textbooks is on page 155. Chose this one to do because I see some pi's, which remember pi is a constant, not a variable. We've got some trig functions in here, and we're going to have to use implicit differentiation. We want to try to find the equation that's tangent to this curve. We want to find the equation of a line that's tangent to this curve at the point 1 pi halves. And then we're also going to find the equation of a line that's normal to this curve at 1 pi halves. So we have to start by doing the derivative because that's what's going to give us our slope of our tangent line. First thing I notice is I have 2x times y, so I notice there's multiplication in here. So that means I'm going to have to use the product rule. So I'm going to take my first expression, 2x, times the derivative of my second expression, so the derivative of y, I'm going to write as dy over dx. You could write it as y prime, but that looks an awful lot like y to the first power, so I'd suggest you don't do that. Plus your second expression, which is y, times the derivative of 2x, which is 2. So that's the product rule. If you're thinking of this as u times v, this would be u times v prime plus v times u prime. Plus. Next, now you see multiplication here, but realize that pi is a constant. It's approximately 3.14159, so you don't need to use the product rule here because I don't see variables on both sides of my multiplication. So when you have a constant multiplied up front, you just copy that constant down. So copy down the pi. Now do the derivative of sine, which is cosine. And we're going to have to use the chain rule because I have an inside function of y, inside expression of y. So I copy down that inside expression, and then by the chain rule, I multiply by the derivative of that inside expression, which would be dy over dx. And then the derivative of 2 pi is about, about a little over 6. So that's a constant. Derivative would be 0. Now you could go through and solve for dy dx first, and that's the way I normally do it, but I think sometimes when you have a tough expression to solve for dy over dx, it's sometimes easier to go ahead and plug in your x and y right after you've figured out the derivative, right after you've differentiated every term is what I want to say. Put 1 in for x, pi halves in for y. So 2 times 1 times dy over dx plus pi halves for y times 2 plus pi times the cosine of pi halves times dy over dx equals 0. So this is going to be 2 times dy over dx plus, here if I multiply by 2 and divide by 2, these are going to cancel, so I'm going to have plus pi times the cosine of pi halves. Pi halves is at the top of the unit circle, cosines are distance left or right, so it would be 0 units left or right. So you can see this whole term here will become 0 because pi times 0 times your derivative y over x, dy over dx, that's equal to 0. So really I just have this left, 2 dy over dx plus pi equals 0. Subtract pi off both sides, divide by 2 on both sides, dy over dx equal negative pi over 2. That is the slope of your tangent line. Now we're going to write our equation of our tangent line. So the equation of a tangent line would use point slope form of a linear equation. So y minus y sub 1 would be y minus pi halves equals your slope of your tangent line, which is negative pi halves, times x minus x sub 1, which would be x minus 1. You could simplify, you could distribute the negative pi halves through, which would give you negative pi halves x plus pi halves. Add pi halves to both sides, and that would give you y equals negative pi halves x plus pi halves would be pi. That would be the equation of your tangent line. The normal line would be the exact same equation, except you need to change the slope to its opposite reciprocal because normal lines are perpendicular to tangent lines. So I'm going to go back up and I'm still going to do y minus pi halves. Instead of negative pi over 2, I'm going to change that to positive 2 over pi. x minus 1. And again, you could distribute the 2 over pi through this time, which would give you 2 over pi x minus 2 over pi, and then add pi halves to both sides, and this would be your equation of your normal line. Y equals 2 over pi x minus 2 over pi plus pi halves. That would be the equation of your normal line. And if you wanted to get, you can see our slope on this line is 2 over pi, but if we wanted to get the y-intercept, we could use a calculator to approximate this value and have a better idea of exactly what the y-intercept is on that normal line.